So first, the graphic for each edge that is usually a great. So only
Good afternoon, sir. I am Prabhakar Dorge, delivering my PhD pre-submission seminar on my topic Design of Panel for Improvement of QS with Different Mobility Patterns, and I am doing this work under the guidance of Dr. S.S. Dorge, sir. These are the details of my PhD registration along with research center, university approval date, registration number, and number of papers published in various international conferences and journals. These are the outlines of my today's presentation. Let us start with the introduction. So vehicle ad hoc network, that is VARIAT, is used for the communication in between vehicles which are present in the different vehicle. So apart from the communication, there are several applications of VARIAT, and these are, we can get safety from VARIAT system, and safety from what? Safety from road condition, collision avoidance, and emergency warning also. Also, by using GPS, we can track any vehicle or any person. If we implement GPS in VARIAT system, so that we can easily know the exact value of your vehicle. This is the generalized VARIAT environment in which we can see that. This is your cellular base station, which covers all the network. There are three types of different communication. First one is communication from base station to vehicle. Second one is from base station to vehicle, and third communication is vehicle to vehicle. Here I have designed this VARIAT system by using WiMAX, that is worldwide interoperability for microwave access, and these are the specifications of WiMAX, which is quite better than Wi-Fi system, which coverage area is up to 50 km and speed is up to 70 Mbps. Also, it has two frequency spectrum, that is one for line of sight, that is 10 to 66 GHz, and non-line of sight 2 to 11 GHz. This can be used for 4G communication system, and second protocol for 4G communication system is LTE, that is long-term evaluation. WiMAX also supports MIMO, active modulation and coding, as well as hybrid IRQ. This is a comparison of Wi-Fi and WiMAX over 0 to 1 scale. Here we can say that black line indicates WiMAX and red line indicates Wi-Fi. So this is the comparative analysis of coverage with Wi-Fi and WiMAX. So here we can see WiMAX has larger coverage area than Wi-Fi. Even quality of service, that is performance parameter, is also better for WiMAX, and mobility is near about same for both one. And price per bit should be less for the design system, and price per bit for WiMAX VARIAT system is quite less as compared to Wi-Fi based VARIAT system. These are the comparison of Wi-Fi and WiMAX. The motto behind this is that why I am comparing these two, because most of the work is done in VARIAT by using Wi-Fi or using GHRCE, that is dedicated short range communication protocol. I am designing this work by using WiMAX. So these are the different Wi-Fi standards, and this one is Wi-Fi. Now the main difference in between this Wi-Fi and WiMAX is that speed. Here we can see its speed is up to 70 Mbps, which is quite better than the remaining three Wi-Fi standards. And then we can see it is a large difference in between this 50 meter, 100 meter, 100 meter and 50 km. These three are the, this one is the Wi-Fi range for outdoor stations, and this one is also outdoor station for 50 km of WiMAX, and these are the remaining specifications of Wi-Fi and WiMAX. Here primary application of Wi-Fi is only wireless LAN, but WiMAX we can use for broadband wireless access. Here I have designed two systems for WiMAX, that is MIMO, that is multiple input multiple output, and AMC, that is adaptive modulation and coding technique. So we know that MIMO is multiple input multiple output, which is used to improve the throughput as well as the channel capacity, in which we send the data by multipath way or by number of way, we can say, or by reflected way, and at the receiver side we aggregate this data. So by using MIMO we can improve the sector efficiency as well as throughput. This is the generalized diagram of MIMO. Transmitter side n number of antennas are there, and at the receiver side m number of antennas are there. When we make equations of transmitted data and signal send data, where RT represents your received data and ST represents your send data, which is RT is equal to H of ST plus V of T. This is the transmission matrix of NR receiving antenna and NT transmitting antenna, and which are the combinations of your H11, H12 like that. where HIJ denotes the complex channel coefficient between J transmitting antenna and the I transmitting antenna, and PTJ equal to P upon eta t. This equation stands for different power required for the different mobile stations or vehicular stations. And this is the transmission model of MIMO, that is R is equal to Hx plus N. Another technique what I have designed, that is AMC, that is adaptive module and coding technique, in which the parameters on the channel continuously differs because noise can be added in the various channels, and there are number of channels, radio channels in MIMO technique also, because MIMO refers to multiple inputs and multiple output, in which there are multiple antennas, number of antennas at the transmitter side as well as the receiver side also. But here we are using radio channels as a multiple numbers, so we are transmitting the data by multiple radio channels. So what exactly happened, I would like to flip this slide. What exactly happened in AMC? First of all, we are going to see exact SNR value of that particular channel, and depending upon the SNR value, we are going to decide which modulation technique we have to use. For example, suppose SNR value is very low, in that case we will use lower modulation technique like BPSK, QPSK. If SNR value is very high, then in that case you will use more higher level modulation technique than QPSK and BPSK, that is 32 QAM and 64 QAM. So this two figure shows the how AMC works. This QAM 64, QAM 16 and QPSK. Let us consider that three users are there, A, B and C. On the top of the building, one antenna is here. Now this distance is quite lesser as compared to this second user and third user. So let us consider that the signal quality of this is good as compared to this one and this one. So that's why here SNR value is quite high. If SNR value is quite high as compared to second and third user, so in that case we use QAM 64. Now compare this second user with first and third one. Here the distance from antenna to second user is quite small as compared to third user. That's why we use here QAM 16, and similarly for QPSK also. If we compare this graph, receiver SIR, that is signal interference noise ratio, with the throughput. Suppose if we are using QPSK, so throughput will be quite less as compared to remaining modulation techniques. Suppose if we are using higher modulation technique like 64 QAM, that is quadrature ambient modulation, in that case throughput will be higher than QPSK, 8PSK and 16 QAM. So this is the generalized graph shows for the adaptive modulation and coding technique. Now
this is all known in literature now. What is your discovery this?
Yes, so directly I will go there. Okay. So what is exactly I am doing, and what is the motivation of work? Recently we all know that Wi-Fi system is based on Wi-Fi and dedicated short range communication technique, which has very short storage area up to 100 meter. So nowadays number of vehicles are increasing. So by taking this consideration, what we decided to make such a wireless system which has large coverage area up to 50 km, or let us say more than 10 km, and that should provide better quality of service parameter than existing wireless system which is based upon GHRCE and Wi-Fi. So what we have done, we have selected WiMAX network rather than GHRCE and Wi-Fi by its special feature of better coverage area, and thousands of users can involve within that coverage area of the WiMAX. This is my problem statement. The aim of this work is to develop different vehicular networks. So here I have designed 3 different vehicular networks. First one is a high-speed highway environment network. Second is variable speed environment network, and third one is city environment network. By using WiMAX network, and we design MIMO and AMC 2 algorithms for WiMAX based wireless system. And finally, we find out 5 different quality of service parameters like throughput, jitter, delay, packet delivery ratio, and packet loss ratio. These are the objectives of my work. I would like to briefly explain all these 5 objectives. I have designed 3 different vehicular network which is based upon WiMAX based wireless system. Then I design and implement MIMO and AMC technique on this design system. After designing awk files are used to find out the different quality of service parameter, and I find out 5 parameters for different routing protocols. Here I took 3 AODV, AOMDV and GSR3 routing protocol as a reactive routing protocol, and DSDV is proactive routing protocol. And finally we analyzed which routing protocol is better than remaining 3 for that particular WiMAX based wireless system. I have referred lots of literature survey paper. methodology. So what exactly how proceed for designing of this WiMAX system? First of all, I designed WiMAX based wireless system by setting some parameter like frequency, then bandwidth, then omnidirectional antenna, whatever antenna we are using, that is omnidirectional antenna, what a propagation model, then what type of routing protocols we are using, what is the packet size, then all parameters first of all we set, then we design the base station at the just center of the our coverage area, and then we design roads and square for three vehicle environment network, and then its source and destination positions, because all vehicles are moving. Then we attach UDP, that is user datagram protocol, and constant bitrate CBR for all the transmitting vehicles, and null agent to receiver, so that we terminate the data at the receiver side, and then form radio channels from transmitting vehicle to receiving vehicle, and finally we transmit the data. This is the main methodology slide. First, after designing a WiMAX based wireless system, we design MIMO and AMC technique, and then implement these two technique on this designed WiMAX based wireless system, and then we start the simulation for different routing protocols, that is AODV, AMDV, DSDV and DSR, and then after designing of OGG files, we find out all 5 quality of service parameter, and we compare them for the particular vehicular environment and find out best routing protocol among that 4 routing protocols. So these are these parameters for different vehicular environments, and here speeder also varies along with frequency and bandwidth. These 5 parameters: throughput, jitter, delay, packet delivery and packet loss ratio we have calculated. Let us start with the result work. This is the we have done this work in NS2 software, that is Network Simulator 2.34 version, and this is the snapshot of network animator. So this small circle indicates the vehicles, and each are having vehicle number. So WiMAX based wireless system is totally different than Wi-Fi or GHRCE based wireless system, because WiMAX is IP based system. Each and every vehicle or base station have its separate unique IP address, and this IP address depends upon the domain we use, whether it is wired or wireless, then cluster, number of clusters, then particular vehicle number starts from 0, 1, 2, 3 up to n value. For example, suppose if you are to provide IP address to 5th vehicle and it is working in wireless communication, so domain is 0 point, we are using first cluster, that is 0, so 0.0.5, it means that wireless domain, 0th cluster and 5th number of vehicle, this is the total IP address of particular vehicle. In this manner we can provide IP address to each and every vehicle and base station. So these are the results obtained for high-speed highway environment network. So this one is the throughput received for AODV routing protocol and AMDV routing protocol. I have taken some of the outputs for communication in between 2 vehicles only, and some outputs for overall system. So we cannot compare this graph and this graph along with DSDV and GHRCE routing protocol, because at the same time communication between 2 vehicles cannot be said. If some vehicle are transmitting the data to other, maybe in a second pair of the vehicle, other vehicle is not transmitting the data to another vehicle. It depends, because all the vehicles cannot transmit the data at the same time. So this is the simulation time on x-axis and throughput of receiving bits on the y-axis, and TIL, that is time interval length, is 0.05 second. So here we can see, and at the 2 seconds of simulation time, here we can calculate whatever data is received at the particular vehicle, that is 1 into 10 raised to power 5 bits at the receiver. So this is for AODV, this is for AMDV routing protocol, similarly for DSDV and DSR. Next one is jitter. These graphs are somewhat very closer to each other. The meaning of that is that these are the sequence number of each and every packet. We are transmitting thousands of packets in the particular time of interval, and here we can see some of the jitter is positive. This is on y-axis, there is jitter. Some of the jitter is positive, some of the jitter is negative. The reason behind is that jitter means the time difference between second delay and the first delay. Let us consider that second packet is staying for longer amount of time in the queue, because first packet is totally not saved in the buffer or at the receiver side, which is supposedly processing. So second packet will stay at the queue for longer amount of time, so that the difference between second delay packet and first delay packet will be positive. That's why it is delay on the upper side is positive. Here some of the delay is negative. Reason is that suppose second packet is for very less time at the radio channel, or suppose at the queue. So in that case, if you find out the delay for second packet and first packet, so the delay of difference will be negative. because first packet delay is maximum than the second one. So lower value minus higher value, it will give negative jitter. This is the reason behind that. So this one is for AODV, AOMDV, similarly for DHDV and DSR routing protocol. And after this graph, next one is delay. Again, this one is for simulation time and delay in second. So for example, let us consider that from time 1 to 2, hundreds of packets we are sending, hundreds of delays are there, and they are very close to each other. And finally, to understand the nature of this graph, we find out the average value of all these graphs. These are for AODV, AOMDV and remaining two protocols. These are the average value of all these graphs. So here we can say that these are 5 parameters for different for routing protocol. Take 1, 2 and 3. These 3 are 1, 2 and DSR. These are reactive routing protocol and DHDV is proactive routing protocol. The reason behind this that we can see here the throughput of DHDV is very less as compared to remaining 3. Reason is that in the proactive routing protocol, what exactly happens? It continuously updates its routing table. So it takes more time, so that here number of packets will be staying in the queue and there will be more packet loss. That's why very few packets will receive at the receiver, so that its throughput is very less as compared to remaining 3. And here we can say AOMDV is better as compared to AODV, DHDV and DSR in terms of throughput as well as in terms of packet delivery ratio and packet loss ratio also. And this delay and jitter are in microsecond. So these are very less value of delay. Similar type of outputs I got for second type of environment, that is variable speed vehicles environment network. So these are the receiving throughput for 2, that is AODV, AOMDV routing protocol, for next DHDV and DSR. Similarly for jitter and then for delay also. Again, all the average values for this graph for variable speed vehicles environment networks. Here again we can see AOMDV performs better as compared to remaining 3 routing protocols. And last environment is city environment network, in which maximum numbers of vehicles are present than other 2. When we check the realistic pattern of the vehicles, in city environment, number of vehicles are more than highway speed highway environment network. So here number of vehicles are double as compared to remaining 2 vehicular environments. These are the graphs of throughput, again for jitter and delay, and these are the special average values of all these graphs. And again here we can see here throughput is more. Now reason for this is that why AOMDV routing protocol have more throughput, because number of vehicles are more in this, number of transmitting vehicles are more and number of receiving vehicles are more, so that we are receiving maximum number of packets at the receiver. That's why the throughput of AOMDV routing protocol is quite better as compared to remaining 3. And yeah, sir, all these results are already published in these journals. Written here which result is published in which journal or which international conference paper. The conclusion of my work is that this all 3 wireless wireless system designed with MIMO and AMC performs better as compared to existing Wi-Fi and GHRCE based wireless system. Also, MIMO technique, by using MIMO technique, we can increase the capacity of the radio link. Why? Because we got a better throughput than Wi-Fi based wireless system, and some of the authors have done their work without MIMO system and they got lesser throughput and maximum delay. So I compare my results with their results. On the next slide I will show. By using AMC also we can use effective use of channel capacity and can achieve higher data rates. I got better throughput and packet delivery ratio as compared to existing system, as well as minimum delay and jitter than Wi-Fi based wireless system. And final conclusion is that among these all 3 wireless system, AOMDV performs better as compared to remaining 3 routing algorithm. And the reason behind is that AOMDV is reactive routing protocol, AOMDV stands for add upon demand multipath distance vector, in which suppose primary route is broken, so it will continuously search for the alternate route, so that it can easily transmit the data without minimum packet loss. And that's why we got maximum throughput and maximum packet delivery ratio for AOMDV routing protocol than other 3. Here review of later paper, that is this first paper on multipath energy converging routing protocol for wireless ad-hoc networks, lifetime improvement. This paper is published in Springer by this.
Please show your and theirs.
Okay.
That is, if you show simultaneously, then you can understand that,
Okay.
where you are with respect to that.
Yes, sir, I will give it.
Go ahead. I think so. This I won't be too keen to see that. If you are only reporting what is their result,
Yeah.
but unless we know their result, your result, you must see that simultaneously.
Yes. In this second paper, which is transition based, they have designed valid system on WiMAX and without Vimo and AMC. They got maximum packet delivery ratio up to 74%, and I got maximum up to 89.84% for variable speed environment network. This is the improvement in speed as well as packet delivery ratio. And next one is they have designed valid system for WiMAX network. This paper is published in 2012 conference paper, and they got throughput of 62 kbps and delay of 0.07 seconds. So I got 6.53 microsecond delay, which is quite lesser as compared to this one, and near about 7 to 8 mbps of throughput for this. But I achieved this
Are you simulating all the other proposed ones?
Yes, sir. I have designed one.
Whatever is the others literature work.
Yes, sir.
Are you exactly simulating what they have done?
Yes, sir. In this paper, this is without MIMO and AMC. Before designing my MIMO and AMC technique, I
Did you
designed
understand my question?
Yes.
Did you understand my question? See, you may read the paper and you may take, okay, his result is saying this much. But if you are taking their approach, making your own simulation, okay? So until we give same data, same simulator, and then only we can compare that, this against this.
I designed this paper, sir, and I found that 74 point something was the PDR.
So this is based upon your simulation of their approach.
Yeah, I use all the their parameter values.
Okay, fine.
These are my publications in international journal. These are available on the internet, and these are all four are IEEE conferences papers. And these two papers are already submitted in Scopus Index journals. And these are the references. Okay, fine.
Any queries or comments from the audience?
Sir, I have one question. Somewhere you are mentioning about the city environment network in the PPT.
City environment network. Yes, sir.
So related to that, in city, why why the throughput of DSR network protocol is very much less?
DSR throughput for DSR in city environment network. So reason behind is that though it is a reactive routing protocol like AMDB and AODB, the reason behind is that there are number of vehicles in this city environment, because in realistic number of vehicles are more in city as compared to highway. So GHRCE has disadvantage that it cannot handle the congestion. That's why it loses maximum number of packets. If number of packets are maximum dropped, and here PDR is very less as compared to remaining 3, so that what will happen? Maximum packets will lose and very few packets will receive at the receiver, so that throughput is very less.
I think so. There is one problem.
Yes.
If you look at the delivery ratio, yes, there isn't so much of difference between DSTV and DSR, right?
Yes, sir.
However, throughput is so much different. So, is it only because of that, or
There is another reason.
yeah.
Yes, sir. So your question is that there is a slight difference in PDR of DSDV and DSR,
Yes.
and there is a lot of difference between throughput of DSDV and DSR.
Yes.
The reason behind is that in DSR routing protocol it cannot handle the conjunction. That's why maximum number of packets are dropped, so that its packet delivery ratio is quite lesser as compared to remaining 3. And here what happened? DSDV is proactive routing protocol. In proactive routing protocol, exactly what is happening?
See, if you just look at packet loss ratio,
Yes, sir.
okay, in the order of packet loss ratio, there isn't so much of difference. Okay. But in terms of the drop in throughput, there is too much of difference.
Yes, sir.
Okay, so I think please look at your data and results once more.
Okay, sir.
So yes, qualitatively you may say this is less, that is more, alright. But if you may just look at those values once again, then perhaps it will get more rationalized. Because if you just look at the data, what we have put here, it is order of magnitude difference.
Right, sir.
So we are not able to understand that from theoretically or the protocol difference and that kind of thing that it is like that. Okay, so maybe you must try to take another look at that.
Right, sir.
Right. Yeah. Is there any other query?
I will have two suggestions.
Right, sir.
Number one suggestion is that you have given delivery ratio and packet loss ratio. They are 100 minus to each other.
Yes, sir.
They cannot be separate parameters.
Just I have not shown the graph of packet delivery.
Anyway,
Yes.
That's what I wanted to tell.
Here we can say there are only 4 parameters.
Okay, this is number one. Number two is that please don't compare Wi-Fi with WiMAX,
Right, sir.
because they are completely two separate category of things.
Right.
Okay,
Right.
so please don't compare. That will be better.
The motto behind comparison of Wi-Fi and WiMAX is that whatever work different authors have done for WANET system or intelligent transport
My
system.
suggestion to you,
Yeah,
sir.
yeah.
My suggestion to you.
I also thought a bit about that, because if you go back to your earlier slides, which is giving number of channels for WiMAX and number of channels for Wi-Fi. Okay, I will tell you. From OFDM point of view, just maybe 1 or 2 slides before this. See, even a bachelor's fellow will tell you, if you just look at 64 channels against 256 channels. Okay, so now this is 4 times more channels are there. Okay, so there is definitely scope for higher this kind of thing. Now the other point is when we are talking about range. If you look at the basic frequency, alright, and those kind of things, from there one may say that suppose if I just increase the signal strength for the 802 to 11, okay, so should I not be able to get the same range as that WiMAX?
Sir, please repeat your question, sir.
See, suppose I increase the signal strength
For Wi-Fi.
802 to 11B and 11G.
Right, sir.
Okay,
Yeah.
I will just increase the signal strength.
Okay.
Okay, then should I not get the same range as the 802 to 16?
So in that case, if we increase the frequency for
I am not saying frequency, signal.
signal strength.
Signal
If
strength.
we increase the signal strength, in that case, what you have to do at the particular difference, we have to design number of access points. So maximum access point we have to use to cover the maximum area. But in a WiMAX network, we have to use only one base station and few access points.
Okay, see, there is some related work actually done quite some time back. It is by one professor of IIT Bombay. Earlier he was at Kanpur. His name is Bhaskar. So his work has already shown that there are conditions under which 802 to 11B can be, its range can be extended quite a bit. It can be not order of meters, order of few tens of kilometers.
So I showed my work to him also.
What does he say?
He came to our college and he said that there is no comparison. Sir also said same thing. There is no comparison of Wi-Fi and WiMAX.
Right.
But after designing MIMO and AMC, your quality of service parameter can be improved, and it is already done.
So see, actually see, here we may discuss and all that, but when we send your thesis to examiner, if you find a serious problem with respect to that, then you will be in trouble. Okay?
Sir, I will answer just your point.
Right, sir.
Sir, and his questions also. If the power is increased, definitely the link budget will allow it to do so, of what professor from IIT has proved. That is okay. Issue is that this is license-free band 802.11b.
Right, sir.
Okay, and designed for small area, local area network.
Yeah, the comparison is not valid because of so many kind of reasons. Okay. Anyway, I have one more serious point with respect to your title. Your title is saying design of WANET. Okay.
Yes, sir.
Now, through all your presentation and all, I am not seeing design. I am seeing only analysis.
Sir, First of all,
Where is the design? Where is the new design?
I have designed VANET system by using.
Sorry, where is your new design?
Sir, I have designed new.
Please show the slide.
Okay. So in methodology, I already explained.
If this is a design, I am sorry. This is not a
This
design.
first block I have written here, design of Wi-Fi WiMAX based VANET system, and I explained in detail how I designed this WiMAX based VANET system.
No, for me a design means much more. Basically, if I understand or I can categorize it correctly, you are trying to formulate the different choice of parameters and approach. I think so. I think that is a more suitable one. Okay. If it is a design, I think so. It means somewhat. According to me, it needs somewhat more kind of things. So you know, I'm not saying that your work is less or anything, but the choice of words which you use. If you say design, okay, sometimes a much more expectation is raised that when you say design. Okay, and that is according to me, because design means you have to take complete blocks of the entire system, and for each one of them you must say that what is your different way of doing that thing. No? So that's why when we say design, we have to be somewhat more careful. According to me, that's my interpretation. Of course, the supervisors and all may be telling. Okay. All right. Then see, publications wise it's all right. Only thing is that the results and the comparisons. No? Already we have pointed out about that. When we get a result, basically you have shown you have shown simulation results, right? Before we come to a simulation result, we must give also some kind of a theoretical expectation. Okay, that as per this algorithm or this analysis, we should expect something like this. Okay, what you actually may prove in a simulation, that may be different, but there should be some, So if you look at the figures of the delay and the jitter, okay, some of those figures are really so confusing. I cannot, you just show me those slides.
They are.
Yeah. Go back. Yeah. These ones. How do you? How can we make some sense out of this? Okay. All sorts of some lines are going in all the kind of directions.
Yes, sir. That's the reason behind is that I already explained for positive jitter and negative jitter. Now, why these lines are like this? Reason is that when we are transmitting, suppose 100 packets we are transmitting. After transmission of first packet for x1 time, it receive at the receiver at x2 time. The delay of x2 minus x1 will give first delay of the first packet. Suppose if you transmit second packet.
No. I'm saying that all that is fine. The point is that you want to prove what here through this figure. What is it I am expected to understand? The fact that your lines are going in all directions and slopes and kind of things. Do you want to show that the jitter is large, or what is it that you want to show through this figure?
From this figure, I want to say that jitter is very less for the particular DSR routing protocol or particular routing protocol. That I want to say. Because this time is very, very less, and when I find out the average of all these thousands of packets value, then it is in microsecond.
Okay, but the figure is a bit now.
Sir, this figure that's why complicated, because in this short amount of time we have transmitted more than 10,000 of packets. So each packet have delay. After delay we calculated jitter. These values are more than 1,000 values. That's why very close to each other.
That's all right. My suggestion is that try to find some better way of showing that.
Right.
Yeah. Okay, I think so. We are done.
Thank you, sir.
With this, we come to the end part, and I am thankful to Professor Negi for traveling all the way from Hyderabad and being here for the very purpose of guiding the PhD scholars before submission of their thesis to the university. And with his exhaustive suggestions, I would like to give a word that all your suggestions will be incorporated in the thesis and the work of the PhD scholars, and we will take due care that unless until this is done, the thesis will not be forwarded to the university. So thank you one and all. And before signing off, I would like to request Professor Negi to please guide the PhD scholars regarding the research issue.
Presentation is there, so we can carry on that.
Presentation will take, it takes time,
In short,
1 hour or something like that, that's the, see, the reason I came with presentation is that because if I say something is not good, okay, if I say something is inferior, then you will ask me, what is good, what is better? So, to tell you that what is good or what is better, I have come ready with the presentation. However, because of the shortage of time, it is not possible for me to go into that. But very briefly, I will just touch upon the important points. From important point, thing is that